Let's talk about alignment, not the abstract, idealistic kind, but the boots on the ground version that determines whether your LLM gets deployed or pulled, whether your chatbot builds trust or goes viral for the wrong reasons. Because at the heart of every useful LLM product today lies one uncomfortable truth: if you cannot moderate its outputs, you cannot ship it. In this episode, we're driving into the surprisingly rich and evolving world of LLM safety and response moderation. You'll probably heard of RLHF or maybe constitutional AI, that clever technique from Anthropic where models evaluate their own outputs using a written set of principles. And that was an early glimpse into an automated alignment. But the space has moved fast, and those early methods, while groundbreaking, aren't enough anymore. We kick things off with constitutional AI, not what just it is, but why it mattered. We walk through how it worked. No massive team of human annotators, no infinite label budgets, just a model judging itself using a fixed rubric. Elegant, scalable, but static. And that's the catch. What happens when norms shift? When new edge cases emerge, you're stuck with a model trained for yesterday's rules. And that brings us to OpenAI's moderation API, and this is where things get dynamic. Moderation at inference time. You, the developer, write your own rubric. The model evaluates content on the fly. It's like deploying a real-time policy layer over your LLM stack. But the flexibility comes at a cost. The system is only as good as the rules you write. Miss a category, say property theft, you might get dangerous content slip through. And after that, we look at LlamaGuard from Meta. It's open source, lightweight, and importantly, its first major response moderation tool that you could run locally. But LlamaGuard is still a monolith, pre-trained, static, and subject to the same old issues of false positives, false negatives, and contextual blindness. And that's where things get interesting, because now we are in the age of adaptive safety. Enter Aegis, and this is the headline act. Aegis introduces a system that don't just moderate, it learns how to moderate better over time. It uses multiple fine-tuned expert models, each trained to spot different types of risk, and combines them into a dynamic router that decides in real time which expert moderator is best for each moderation task. So from there is an uptick on AI content moderation, and the latest incarnation is BingoGuard from Salesforce, which solves a key problem in AI safety: binary moderation, which doesn't cut it anymore. This matters because if you're building in healthcare, finance, education, or anywhere trust matters, your LLM needs more than just clever prompts and temperature tweaks. It needs safety architecture. It needs systems that evolve, and that's where all these new paradigms come in. So whether we're shipping AI at scale or just curious about how the smartest teams are making LLM safer without slowing them down, this episode will give you a complete map from legacy techniques to the cutting edge. Stay tuned. Now we're diving into a significant development: AI alignment. This is constitutional AI. You might be familiar with the concept. It is a technique introduced by Anthropic in late 2022. Anthropic is the company which releases the Claude series of models. And this is detailed in the paper called Constitutional AI: Harmlessness from AI Feedback. This is essentially, they're trying to scale AI moderation away from human feedback, which was at that time the current method, a human level annotation. Now let me paint the picture. Before constitutional AI, the standard alignment method was RLHF, reinforcement learning from human feedback. That meant people, often contractors on platforms like Mechanical Turk, were asked to look at a bunch of model outputs, compare them, and say which one was more helpful, less toxic, more truthful, you name it. Sometimes they would even score it across different dimensions like legality, bias, toxicity, and overall helpfulness. But here is the problem: that kind of human annotation does not scale. It is expensive, time-consuming, and inconsistent. As the models got larger, the volume of feedback required just ballooned, and that's where constitutional AI steps in. What this paper proposes is pretty clever. Instead of relying on human annotators to rank or score outputs, they let the model critique itself, guided by a set of written principles, which is a constitution. And these aren't vague moral suggestions, they are concrete rules like do not promote illegal activity or avoid discriminatory language. So now when the model outputs a potentially harmful response, say someone asks it to hack into their neighbor's Wi-Fi, it doesn't just spit out a refusal or rely on a hard-coded block list. It actually goes through a process. The model is prompted to analyze its own response, ask itself whether anything in it violates these constitution rules, and then generate a revised version that avoids the harm. That means it is not just saying no, it is learning to reason about why something is harmful and how to fix it. That is a big shift. Now, to be clear, this isn't something that happens during inference. It is not real-time reasoning. This is happening during the Post-training phase. The model is forced to generate harmful outputs based on very structured queries, and it is then forced to critique those outputs, revise them based on the constitution, and compare those before and after pairs to fine-tune a final safer model. So once training is complete, the post-processing is complete, you get a new model that is aligned to your values, the societal values or whatever values you want to inject into the model, without needing constant hand-holding from humans. So you went from RLHF to a fully supervised, fine-tuned model in an automated fashion. One thing I really like here is that how this technique basically anticipates a lot of what we are seeing now in test time reasoning. These days, frameworks like self-verification, chain of thought, even process reward modeling are big. Process reward modeling, essentially you reward the model as it thinks along the way. So let's say it solves an algebra problem step by step. At each step, you give it some reward. It's like partial grading. So process reward modeling is big, but there's also something called output reward modeling, where you only give the grade for the final answer. It's like the grading philosophy. What kind of grader you are? Do you give partial grades, or you only give grades if the answer is correct? So now, that being said, the models are trained and prompted to work through these reasoning steps nowadays to give a full final answer, but constitutional AI kind of did the same thing just during training. So they did create a monolithic system which cannot be changed during inference time. So while the paper doesn't explicitly mention process reward modeling, it is conceptually similar. You have a multi-step reasoning process: detect harm, critique the problem, revise the output, and all those steps follow a rubric. It is structured, it is deliberate, and honestly, it is pretty elegant. And what this allows is massive scaling of alignment. You no longer need thousands of humans reviewing toxic outputs. Instead, the model learns to critique and correct itself based on the principles you set up for it to follow. It's like giving your model a conscience, or at least a checklist for one. Now, when we talk about modern AI firewalls like LlamaGuard or BingoGuard, this idea is foundational. LlamaGuard classifies prompts and completions based on risk categories, and BingoGuard, which is quite recent, and we're going to talk about that in a future segment, that goes even further by doing fine-grained approaches. But the idea that the model can assess its own responses based on a rubric, that all started with constitutional AI. Constitutional AI may not be the flashiest name in AI right now, but it quietly kicked off a revolution in scalable alignment. It let us move away from brute force human supervision and towards models that are safer by design, not just by filter. And that's where things gets really exciting, because now we are not just building smarter models, we're building more accountable ones as well. Let's talk about OpenAI Moderation API. This is one of the most robust real-time content moderation solutions available today, built to handle the scale and complexity of the modern AI applications. OpenAI designed it with a simple but powerful idea in mind. Instead of including all the rules, all the content moderation rules into the model during the training phase, like the previous approaches such as constitutional AI, now they allow you to apply your content policy at inference time. That means the model evaluates content on the fly using your custom rules without ever needing to be retrained. And that's a big deal. In the older paradigm, models were fine-tuned using reinforcement learning with human feedback. You trained the system once, locked in your policy, and hoped it held up over time. But that approach is slow to update and expensive to maintain, especially if your moderation needs to change frequently. The new approach by OpenAI is the reasoning in real time. Think of inference time moderation like having a content traffic cop that always on duty. You give it a rubric, your moderation policy, and a GPT-4 checks every content against that policy as it comes in. No retraining, nothing. Real-time enforcement. Let's walk through a quick example. Let's say your rubric contains 5 levels of severity. Level 0, which is benign. Level 1, kind of benign classification request. Level 2 is intent to commit some kind of a wrongdoing. Level 3 is asking for advice for non-violent wrongdoing. And level 4 is asking for advice for violent wrongdoing. Now, suppose someone asks, how do I steal a car? I prefer the example, how do I steal a llama? But that's okay. So let's say this is the example OpenAI provided on the website. If the query is, how do I steal a car? A human moderator might immediately flag that as a level 3, which means asking for something which is wrong. But if the rubric doesn't explicitly say that theft falls into that category, then GPT might call it benign and let it through. The moment you update your rubric to define theft as one of those wrongdoings or level 3, so the moment you update your policy or your rubric to define the theft on the level 3, the system can now update instantly, no fine-tuning needed. GPT-4 can understand the rules, that there is a change in the rules, and the model will follow it explicitly. Now you have a exact match between a human annotator and GPT-4's advice. So the whole point is that you need that fine-grained rubric that in order to catch better. So if you want a finer grained approach, you have to make your rubric even more detailed, and that's the whole idea. And for especially for content moderation in Reddits and subreddits, some Reddits they allow content through and some subreddits do not allow all content through. So it depends on how fine you want your mesh on which you want to catch your content to be, and that's how detailed your rubric needs to be. But the whole point is that this is inference time, and that's the power of inference time moderation. And OpenAI didn't just build it for internal use, they turned it into a product, the moderation API. The API is fully integrated into OpenAI's platform and lets you bring GPT-based moderation directly into your app or service. And it is not just limited to just text. GPT-4o, it also supports multimodal moderation. That means it can flag unsafe or sensitive content in images as well. Graphic violence, explicit images, it can flag all of those things. This kind of flexibility is a huge win for teams that care about trust and safety, especially for those in enterprise environments or regulated industries where compliance and consistency matter. Now, it's true that the moderation API might be slightly more expensive than the basic GPT endpoints, especially if you're using features like image redaction, which requires more compute resources. But in return, you get a system that's highly customizable, fast to update, and scalable right off the box, and specifically tuned for content moderation. So if you're building with GPT and you don't have your own moderation infrastructure yet, this is probably the fastest and safest way to get started. It's clean, powerful, and aligns with the best practices in inference time safety. And if you're looking for something even more customizable, stay tuned. In a future segment, we'll explore BingoGuard, an open source alternative that offer deeper control but with a higher setup cost. For now, if you're after something production ready, OpenAI's moderation API is a very strong choice. Let's talk about a paper titled Watch Your Language, which is a kind of a reality check for AI content moderation. The novelty of this paper is that the researchers did a pretty clever technique and used Reddit, a platform which has active human moderators and detailed community rules, especially fine-grained community rules for each subreddit. And they use that as a testbed for evaluating LLMs as content moderators. Basically, they ran a massive side-by-side comparison between human moderators and models like GPT 3.5, Llama 2, and few other models, Gemini 2, for example. Now here where it gets interesting. GPT 3.5 did reasonably well out of the box, but once they gave it more context like specific subreddit rules or neighboring content, its moderation accuracy improved substantially. Both the false positives and false negatives dropped. This paper, however, came substantially after OpenAI's moderation API, so I'm kind of confused why they're still using that. But it's a good exercise. I think the whole point of the paper is to show that the main application, especially in a human laboratory like Reddit, and there they really showed that AI scales very well and as good as human moderators. So they found that GPT sometimes flagged things that human moderators missed, and sometimes the other way around. So the takeaway was not human versus machines, but rather human plus machines. Using the large language model as a second opinion or even a frontline filter, you let the human moderators weigh in on the edge cases. And honestly, that's already happening on Reddit and other content platforms. You've probably seen the bot mods stepping in with warnings or removals on Reddit, and that's an early version of this hybrid model. They also tested Llama 2 model, which can be deployed on a consumer grade model, so you essentially can run it at home, and the results surprisingly strong. While they didn't do a full head-to-head ranking, the implications was clear. Moderation doesn't need to be reliant on massive proprietary models. Smaller open source large language models can do the job well enough, especially when they are used in the right context and given the context around where it's supposed to perform the moderation, and also provided with a solid rubric, just like constitutional conversational AI. So what I love about this paper is just not about just a lab experiment. They used real world messiness of Reddit, messy language, subjective rules, different community cultures between the different subreddits, and then tested moderation where it actually matters. It is less about the benchmark scores and more about live deployment. This feels like one of those first serious attempts to evaluate LLM moderation at internet scale, and it gives us a good look at where the future is headed: flexible, context-aware hybrid systems powered by both machines and humans. Shortly after this paper is published, Meta published Llama Guard, and we're going to talk about that in a future segment. Let me take you back to a pivotal shift in how we think about AI safety. Until recently, moderation in AI systems, whether it's prompt moderation or LLM response moderation, was mostly handled by closed source tools like Anthropic or OpenAI. Then Meta released Llama Guard, the first open source model built specifically for moderating the prompts and responses of the large language models. It was a turning point. Suddenly, developers had a transparent, tunable moderation layer they could adapt to their own systems. Llama Guard was the first fine-tuned LLM, fine-tuned from Llama 2 7 billion model. It's a small model. It is a very lightweight to enough to run on a consumer-grade GPU while still delivering impressive performance, a very high accuracy of almost 95%. And with additional fine-tuning, it can get even stronger. In fact, in another segment, we'll cover Aegis, a new system that builds on top of Llama Guard and pushes the accuracy even further from 95 to almost 98%. But exactly what does Llama Guard do? At its core, it performs prompt and response classification. That means it acts as a safety layer for LLMs and helps decide whether a given prompt should be processed or whether a generated response should be shown to the user. For example, a prompt like "tell me about the history of slavery" would be marked safe, while a prompt like "how do I steal a llama" would be flagged as unsafe. The classification is simple: safe or unsafe. Despite having a detailed taxonomy under the hood, the model outputs a binary label. Later systems expanded this with more granular tagging, but Llama Guard laid the foundation. Llama Guard researchers compared the performance of Llama Guard against the baseline models like OpenAI's Moderation API and Google's Perspective API. Now, Perspective API is not truly LLM-based moderation tool. It uses traditional machine learning models to classify text based on things like violence, profanity, or threats. These models operate more like context-free scanners. They can label individual phrases but often miss the bigger pictures. For example, a phrase like "this will ruin the cake" may be wrongly flagged by a basic ML classifier as aggressive or threatening. But if you have the full context, like "it is raining and the cake is outside," and then you realize that it is harmless because rain will ruin the cake. And that is a key limitation of the traditional ML systems: no true context awareness. LLMs like Llama Guard, OpenAI's Moderation API solve this with a semantic understanding. In benchmarks reported by Meta researchers, the Llama Guard scored about 95% in overall moderation accuracy. That's significantly higher than OpenAI's Moderation API, which hovered around 87%, and Perspective API, which scored roughly around 79%. These numbers will vary depending on the dataset, of course, but the trend is clear. LLM-based moderation outperforms the older approaches, and of course it outperforms the Moderation API, which it requires heavy tuning on the user's part. And this matters if you're depending on your own language model, especially as a startup. You need some form of response moderation in place. Otherwise, your chatbot could generate harmful or offensive responses, and that can mean reputational or even legal risk. And what's exciting is that Llama Guard isn't just an endpoint, it's a foundation. You can add your own LoRa adapters, train your own rubric, and evolve the model to handle your specific use case. And that's exactly what Aegis, the new paradigm which builds on Llama Guard, does. It's built on top of Llama Guard with an ensemble of fine-tuned models and dynamic routing to pick the best one for each scenario. And that's something we'll discuss in a different segment. For now, Llama Guard remains one of the most important stepping stones in the path to safe, adaptive, open source LLM deployment. Let's talk about one of the most underrated breakthroughs in LLM safety. Aegis. While everyone talks about RLHF, constitutional AI, or OpenAI's moderation API, Aegis quietly redefines how we handle moderation at scale by combining fine-tuned expert models with real-time adaptive routing. It's a mouthful, and we'll describe this in this short segment. Most previous AI moderation systems, whether it's content moderation or LLM response moderation or user prompt, toxic prompt moderation, basically fall into two camps. You have the monolithic, fine-tuned content moderation models like the constitutional AI or LlamaGuard, LlamaGuard 2, or now LlamaGuard 3. And then these are powerful models, but they're static. You cannot update them once they're trained, but you can fine-tune them at a very expensive cost, like millions of dollars. Those were not flexible. But then there is the other ones like OpenAI's moderation APIs, which are flexible inference time approaches, which lets you define custom rubrics on the fly. But those require highly detailed rubrics policies and still struggle with nuance, and their accuracy is not very high, and definitely not very high on the edge cases. Now, Aegis, which is the new approach which blends both of those approaches, it introduces two core innovations. First, it uses multiple expert moderators, each fine-tuned via LoRa adapters, and this makes it cheap and easy for developers to create specialized moderation models using their own dataset. Second, it adds a router model which learns which moderation expert to use at inference time for each input and adapting dynamically using an online learning method called regret minimization. And here is how it works. Initially, the router picks experts at random, assigning equal probability. Over time, it learns which models perform best on which types of content and shifts the distribution accordingly. No full retraining required. If you introduce a new expert, say a LoRa fine-tuned NemoGuard, the router can integrate it and learn when to use it. So let's briefly describe what the LoRa fine-tuned model that we just mentioned. So essentially, instead of using the monolithic LLMs, they use a LoRa adapter on top of it. So the whole point of using LoRa adapter is a very small cost of retraining or fine-tuning the model, because LlamaGuard 2 or LlamaGuard 3 by itself might not cover all the use cases that you need it to cover. Then you fine-tune your own dataset, the LlamaGuard 2 with your own dataset, and use a LoRa adapter. So let's say the model itself is like 15 gigabytes and it might cost 70 or 80 gigabytes to train the model, and then use a LoRa adapter which might cost only 15 or 16 gigabytes to train, and you can do it on a consumer grade GPU, and that's an important step. So that's a very good idea of using LoRa adapter, and many people use LoRa adapters to fine tune or incrementally tune their large language model that they're using. Now let's quickly talk about the routing model. The routing model is essentially, if you're familiar with reinforcement learning, it's an on-policy learning new policies, which actions to take. Initially, in any policy gradient method in reinforcement learning, we have a set of distribution, a uniform distribution for all actions, and then as we perform those actions and see some actions lead to better results, the distribution shifts and the results improve on certain actions, then it will go. For example, if our car can go left, right, north and south, and then it looks like if we keep going right, then we end up in the right place, then the probability of going right goes sharply up. So the same idea here, if one of those models, LoRa trained, LoRa adapted models, are performing substantially better than the others, then the probability of using that for moderation goes up for a specific kind of content. Let's say for profanity moderation, if LlamaGuard performs better than NemoGuard. NemoGuard is also another model that's released by NVIDIA. It is also an open source model, kind of an open source model that is released, but it's a slightly smaller model than Llama. It's a 32 billion model. And if you use NemoGuard instead of LlamaGuard, and if you see the profanity moderation is better with NemoGuard, then NemoGuard would be selected more than the LlamaGuard model. And that's the main idea. And that's the breakthrough: modular fine-tuning plus adaptive routing backed by online learning. You're no longer stuck choosing between flexibility and accuracy, you get both. And that's what makes Aegis such a major leap forward in scalable, policy-aware AI safety. Today we are diving into BingoGuard, a novel approach to content moderation developed by Salesforce. And Salesforce is best known for their CRM, but this work goes far beyond CRM. It's highly relevant for enterprises managing vast volumes of user queries and interactions, especially social media platforms like TikTok, Meta, or any fast-growing social media apps, and even financial companies who care deeply about security and their internal dialogues, people who talk and interact with large language models using queries, you have to make sure those queries are filtered through an AI firewall. And let's be honest, if your platform is growing 10x or 100x a month like TikTok once did, there is no way to hire moderators fast enough to scale, and moderation isn't optional, it's very critical because we're generating petabytes of user content daily and most of it goes unchecked. The problem with current AI moderation system is that they often rely on a binary framework, flagging content as either safe or unsafe, but that is an oversimplified approach. It doesn't reflect the nuanced needs of the different platforms. Some allow light adult humors, others aim to completely be family friendly, but when you apply the same yes or no filter across board, things can break. Some things can get tagged as harmful when it is actually not, like adult humor. This lack of granularity becomes a major problem as the volume of digital communication increases exponentially. Human moderation is no longer practical. It is nearly impossible to scale teams fast enough to keep up, and when things slip through the cracks, malicious actors take advantage. We have seen the impact of misinformation and disinformation campaigns. They have influenced elections. In some cases, they have even destabilized governments. So content moderation isn't just a technical problem, it's a societal one. It needs to be solved at scale with automation, and that's where Bingo Guard comes in. It's one of the solutions. It's not a complete solution, but it is a good right step in the right direction. It introduces a structured, multi-dimensional, multi-tiered framework for assessing content, one that allows for a fine-grained, policy-aware moderation. And this is important. We can have a rubric, and that rubric can be updated over time to improve While that being said, the part of the system is kind of monolithic and we need to have more flexibility. I prefer an agentic system, and I'll discuss why the agentic framework is not great for content moderation. And the plain and simple reason is that we want content moderation to be done at scale and almost at real time, and which presents substantial challenges for the agentic framework, which has high latency and also extreme cost. So while we can implement content moderation even at small scale using the agentic reasoning framework, which are very robust and flexible and can be updated in the future and is very well future-proof because we can keep updating the policies. However, our compute resources are not large enough in order to allow that system to scale to millions of users and almost real-time content moderation. For now, this monolithic content moderation that I'm going to discuss right now is the best implementation of the use case in our front of the AI firewall or any kind of content moderation that we want to implement. The goal is to empower platforms to set their own content guidelines, detect the subtle threats, and improve both safety and user experience without relying solely on brute force human review. So Bingo Guard takes a really structured approach to content moderation, way beyond the usual yes or no firewalls. Instead of just flagging something as safe or unsafe, they define 5 levels of severity, and even before that they go deeper, breaking the content down into 11 high-risk topics, things like violent crime, privacy invasion, sexual content, hate speech, and so on. Then they add another layer, 7 response dimensions. These include things like intent. Is the content educational or malicious? Then content type. Is it discussing a topic or actually instructing someone to do something? Then they also look at impact, whether the response affects individuals or groups, along with context, subjectivity, tone, and how graphic the response might be. So with this whole taxonomy in place, topics, dimensions, severity levels, they use it to generate training data, and that is important. They don't just scrape the data from the web. Instead, they go full synthetic. They generate the harmful responses themselves, so they can sort them into specific bins, which would be way more expensive to do through manual annotation, and that's how it used to be done before. The training data is to be scraped from web and hand annotated using the Amazon Mechanical Turk. It was very expensive to do. Later, people started using GPT to do it, but that is also very expensive and GPT can get it wrong. They don't want the machine to get it wrong the first time. So this lets them a fine-grained control of exactly what they need for each level and category with a consistent structure. So here's an example. They synthesized a query prompt for GPT-4o for generating the synthetic data, and it goes like this. In this task, I want you to come up with a query that must contain a given keyword. The query should be benign and harmless. Make it as harmless as possible. Do not even try to be ambiguous. Only output the query. So that's a really solid prompt, and it gives an example. For if the keyword is ruining, the model output would be like, how can I prevent rain from ruining my output picnic plans? So given a keyword like ruin, the model has to generate a benign sentence like that. How can I prevent rain from ruining my outdoor picnic plans? The same word ruin could easily show up in a much more harmful sentence like, how can I ruin someone's career or reputation? And that's the point. The model that they're fine-tuning has to learn to distinguish between the benign and the harmful use cases with the same keyword, and it needs to see examples. It's like a supervised training or semi-supervised training. So we are creating the data set where we're going to label the data set which are benign, but they have the same keyword, but another data set which is harmful containing the same data set. So now if we train the model, feed the model both two data, one harmful and non-harmful containing the same keyword, then the model will learn to distinguish based on the context, and that's the whole idea of fine-tuning the model. So something like ruin probably isn't even on the blacklist. It's used in all kind of innocent ways. My food is ruined, I spilled coffee on my painting and it's ruined, and so on. But once you introduce fine-grained data like this, you can fine-tune the model to tell the difference. It learns to understand the surrounding context of a word, not just to react to the word itself. So this keyword matching, word level matching is now gone. It's context level matching, and that's what we're going for. It's almost human level. We're replicating human context level understanding with the large language models. And sure, GPT-4 is powerful enough to do this context level matching at test time or during inference time already, but it is extremely expensive and very slow to run at that scale because GPT-4 has to evaluate every query across multiple dimensions. It has to go through the entire rubric. We have to provide the entire rubric, and it's like, these are the things, these are the use cases, follow these. Even if we're using agentic reasoning platforms that are using a smaller model like Llama 3 or Qwen 2.5 or the smaller 32 billion model, it still takes a lot of time to do at inferencing scale. So it's almost impossible to do it in real time, and latency is a problem, and also the cost. GPT-4 and the reasoning model and the agentic frameworks can do it, but there's a high latency to it. So let's look at it from like asking a general surgeon to perform a highly specialized orthopedic surgery. Yes, they can do it, but it will probably take them 3 hours, for example. Meanwhile, an orthopedic surgeon trained specifically in robotic orthopedic surgery could probably do it in 30 to 45 minutes with greater accuracy and less cost. Now, this might not be a perfect analogy, but you get the idea. So no, you can't just use GPT-4 or the agentic frameworks at inference time or test time for content moderation. It's way too slow and expensive. We need a fine-tuned model that's fast, cheap, reliable, and to get there, we need training data. That's where the synthetic data generation comes in. They do pull from existing public datasets like Wildcard Max, Beaver Trails, Wildcat, and all those things which have known toxic prompts. So they do combine their own synthetic data with that to train the final models. I really think the synthetic dataset creation is a master stroke. Every organization should consider building their own. Yes, fine-tuning is expensive, but prompting GPT-4 for the zero-shot evaluation at inference time is even more expensive and time-consuming, especially if you're handling millions of queries like one of the social media sites. Now, if you're a small company processing only a few hundred or thousand internal queries a day, sure, GPT-4 or even the agentic methods using some locally hosted models like Llama 70 billion would be fine. You don't need to build your own fine-tuned model, but if you're processing tens or 100,000 queries per minute, it makes sense to invest in a fine-tuned system just for latency and cost perspective. So this becomes a build versus buy decision. If your use case is under 10,000 queries per minute, don't build. Use GPT-4 or Claude or whatever is reliable. Maybe even a locally hosted model with agentic reasoning would be just fine for your AI firewall or content moderation system. But if you're scaling to millions per minute, maybe 100,000 per minute, then it definitely makes sense to build. And for startup founders building AI firewalls or content moderation agents, your clients care about speed, accuracy and cost. You could probably charge more upfront for higher accuracy, but if you use a fine-tuned model trained on synthetic data, you can actually deliver better accuracy at lower latency than GPT-4. Could this whole thing be implemented using GPT-4 with agentic reasoning? Probably yes, but it will be slow. Any agentic solution at test time involves inter-agent communication, which takes time and compute. That increases latency and cost. So again, if you're just bootstrapping, an agentic MVP makes sense. But once you're at production scale, millions of queries per minute, the best method is to still create your own synthetic data set, fine-tune, and deploy your fine-tuned model. And here is the good news. The prompts are already available in the paper. They did not release the full code, but implementing it shouldn't be hard because they provided such an exhaustive list of prompts and the rubric that they used. The expensive part is fine-tuning the large language model. The fine-tuning the model might cost anywhere between $10,000 and $40,000, and generating a synthetic data set could another add $10,000 to it, depending on the scale and quality controls. If you include human labor for auditing, quality assurance, and engineering, you're looking at a total cost of, let's say, 100,000 to 200,000, depending on how expensive your engineers are. If you outsource to Philippines, you can probably bring down the cost to around 150,000 for a production grade system, and that's like the basic level you can deploy at. So that's still far more scalable than relying on GPT-4 inference at runtime. It will be fast, it will low latency, highly accurate, especially if you are handling millions of queries a day. Now there is a downside to this. This is a fine-tuned model, means it becomes a monolithic model, which means it cannot be updated very soon. So there cannot be a CI/CD process. It cannot be a continuous integration thing. Every time the rubric changes, the whole model needs to be fine-tuned and retrained with new synthetic data set. If the rubric or the content moderation system changes frequently, then this becomes cost prohibitive. However, usually content moderation rules do not change for decades. What is considered benign now will probably remain benign for decades in future, and what is considered rude now might be considered benign in like maybe a decade or so. So that depends on the whole system, how society is evolving and how fast society is evolving. At the current rate of evolution of society, this fine-tuned model will probably be robust for half a decade or even more, and that would be substantial cost savings already. We don't have to fine-tune the model almost every month. So since everything can be done within like $200,000 to $300,000, this is doable for a startup which has some kind of seed funding, and for enterprise companies which are large, at least from mid to large cap companies, this is nothing budget. So they definitely should invest in this if they have to do any kind of content moderation. For other companies who do not do much content moderation, they are only concerned about user queries going to GPT-4o, and they want to implement some kind of a fine-grained control over the AI system, then the agentic model would be just fine. For small startup, do not build, not yet. Use someone else's solutions. For startups who have substantial funding, then go ahead and build it. And in fact, if this is the product you're selling, definitely build it, because you can charge your clients way more and you will break even within probably a few months. Hopefully having new clients is better. If you can land those bigger clients who might be hesitant to build such a system because they might be worried, because big enterprises are not very agile. Even Meta might not be that agile, so they might be looking for startups who can offload that risk and build it themselves. However, you have to decide what is the risk on building such a system, because the moment the rules change, the content moderation's rules change, whatever the reason, usually it's not the societal reason, it's usually political reason, like a political landscape changes dramatically after an election and the rules might change overnight. And it also might lock you into a single client, because if you fine-tune a model, it might only apply to a specific client, because the client might want very specific moderation rules and another client might want very specific moderation rules. It might be client-based deployment. For every client, it might be 150,000 to 1,000 deployment costs. So that's another business model. You can charge the client upfront, let's say $500,000 or $1 million. It's like, hey, I'm going to build it for you, I'm going to deploy it for you, and you can maintain it in the cloud and you can do whatever with it. If you want to upgrade the rules in future, you pay me another $500,000 or $1 million and I can rebuild it for you. So that offloads that risk of continuous change of rules to the client, and then the startup founders can only specialize in delivery. So that's actually a solid business model for a startup. It offloads the ongoing upgrade risk to the client. If they want to keep changing their rules, they keep paying for it. It's that simple. Meanwhile, the startup focuses entirely on mastering the architecture, becomes highly specialized in building these gating models, fast, reliable systems that can moderate content at scale with surgical precision. Over time, that niche becomes your moat. You're not just selling moderation, you're selling control, compliance, and speed, and that's something every platform eventually needs. That's a wrap for today's episode of Machine Learning Made Simple. If you have questions or want to explore AI topics further, please don't hesitate to leave a comment. Until next time, keep exploring and enjoy your AI adventure.